Hey guys, welcome back to another video, and today we're going to be solving the Leet code question. Find a corresponding node of a binary tree in a clone of that tree. Alright, so this question in itself is pretty simple. All it is really is a tree traversal question, but let's just go over the question real quickly. Alright, so given two binary trees, original and clone, given a reference of a node target in the original tree. Okay, so one thing you really want to understand is that target is a node, okay? And it's a node of the original tree itself. It's not any sort of value, but instead, target is a node of the original tree. So do understand that. Okay, so the clone tree is a copy of the original tree. So the clone tree is exactly the same as the original tree. Now return a reference of the same node in the cloned tree. Okay, and note that you are not allowed to change any of the two trees or the target node, and the answer must be a reference to a node in the clone tree. Follow up, solve the problem if repeated values in the tree are allowed. Okay, so to solve this or to understand this follow-up, you first need to understand that target is a node of the original tree. I know I repeated it quite a few times, but yeah. So the reason I am repeating it so many times is let's look at an example over here. So our original tree is 7, 4, 3, 6, and 19. And the clone tree is going to be exactly the same thing. Now the target that we're looking for in this case is 3. Now again, 3 is not a value. Instead, it's the node inside of only the original tree. So that's also another reason that the original tree is important, because so instead what we could have just done is we could have just gone to our cloned tree and looked for the value 3 and just submitted that, right? So that would have been a lot faster as well. Actually, it wouldn't change much, but yeah, we could have done that. But in this case, we have to look at the original tree as well, because we are comparing the nodes with each other, not the values. Okay, and that also brings up our follow-up, which is the fact that, so let's say we had another 3 over here. So instead of 4, let's say this value was a 3. So in that case, what would have happened is, regardless, we would have only searched for this 3 over here. And again, the same reason is because we're looking for the node and not the value. Okay, so real quickly over here, so we found that the target that we're looking for is 1 to the right of is the right child of the root. So that's exactly what we end up outputting, but instead we output the same thing inside of our clone value, which is 3 over here. So let's just look at one more example actually, and let's just look at this example, and same thing, right? So we're looking for the 5th node, so the node 5, and in this case it's over here for original. So all we do is when we find it, we return whatever is at the same place but for cloned, okay? So now, as it is, okay, like I said earlier, this question really just comes down to a simple tree traversal problem. So as with most tree traversal problems, there's 2 ways to solve it. So you could use something called a depth first search approach, also known as a DFS, or you could use something called a breadth first search approach, also sometimes known as a level order traversal. Okay, so in this video, I'll be using the BFS approach, and I'll just go through what that actually means. And the main difference between both of them is that, so let me just show you what the actual difference is. So let's take this binary tree, and let's say we want to do a BFS. So if you wanted to do a BFS, you would go by each level, right? So you would first get 7, then you would get 4 and 3, and then you would get 6 and 19. So you're going level by level, which is why it's also known as a level order traversal. But if you're doing a DFS, you recursively get these values by depth. So you would first get 4, then you would do 7, then you go to 6, then 3, then 19, and so on and so forth, right? So they're just 2 different ways of doing it, and there's not too much of a difference in terms of getting the final answer. All right, so real quickly, we have our original tree over here. So what I'm going to do is let's create a clone of this. It has the exact same values as our original tree. Okay, perfect. So now what we're going to do is I'm going to show you how we could do a breadth first search traversal, okay? So it's pretty simple, and to do this, we're going to have a stack, okay? So our stack over here is going to contain the nodes, okay? So in this case, what node are we going to end up starting with? So the first node that we're going to start off with is going to be whatever the root node is. So what's the root node in this case? So in this case, the root node is 7. So we're at the original value, 7, and we're going to keep traversing through this. So we're first going to go to node 7. Then we're going to go to its left and right children, and so on and so forth at each node. So at each node, we're going there, right? So in this case, we go to 7. We're going to add its left and right children. So we're going to add 4 and 3. And then we're going to keep continuing the process. Now we're going to go to 4, and we're going to look at 4's left and right children. So in this case, it's actually none, so we don't do anything. Then we go to 3 and look at its left and right children, which is 6 and 19. So that's the process. I'll just go through it step by step now. Okay, and one more thing that we do want to keep track of. So over here, we're storing the node value, and we're storing the node value of the original node itself. But really, we want to end up outputting whatever or wherever we find the same value in the clone. So to kind of make it a lot easier for us, we're going to be storing both of these values inside of our stack. So we'll be storing a tuple value, and our tuple or tuple, however you're supposed to say it, is going to have the original value. I'll just call it OG, comma, clone, okay? And this way, when our OG value is equal to our target, then in that case, we can just directly end up returning whatever the value is of our clone instead of doing the traversal for a second time for the clone, okay? So let's see how we can do it now. So like I said earlier, we're going to start off with the root nodes. So we're going to have the root node of the original and the root node of the clone, okay? So 7, 7, and again, these are not numbers, these are the nodes, okay? 7 refers to the node 7, not the number. So 7, 7. Okay, and let's just put a target here, and I'm just going to say the target is equal to the node 19. So 19, just to be clear, is a node at original. So we can only compare it with original, okay? 19 is a node at original. Okay, so now we have 7, 7. So the first thing is we're going to check if this value over here is equal to our target. Well, it's not, right? So in this case, we're going to pop it out. That means we're going to just get rid of it or remove it. And now the values we have are 7 and 7. 7 for original, 7 for the clone, okay? So now what we're going to actually end up doing is we're going to end up traversing to the left and the right of it, right? So we go to 7 and we check, does it have a left child? It does. So we're going to append that to our stack. So 4, and simultaneously, we're going to do the same thing with the clone. So we're also going to append whatever is to the left of 7. So we're going to have left of 7. Well, in this case, it's going to be 4. So 4, 4. But even though they have the same value, they are different nodes. So now, after getting the left of 7, we're also going to check if there's anything to the right of 7. So in this case, there is a node to the right of it, which is the number 3, or node 3. So we're going to do the same thing. So we're going to get 3 from the original, and we're also going to get the 3 from our clone. So 3, 3. Perfect. Okay, so now we're going to repeat the steps, and we're going to keep doing it until we find our target. So now we're going to get this one, so let's pop it out. And the values that we actually have over here are 4 and 4. So now in this case, is the original value equal to the target? It's not. So we do the same thing. So at 4, we're going to check if it has a left and right child, and if it does, we add it to our stack. In this case, 4 does not have a left or a right child. So in that case, we're actually not going to end up doing anything. So we're done with that. And now we're going to remove the next value in our stack, which is 3, 3. Okay, 3 for original, 3 for clone. So now we're going to check, is 3 equal to 19? Well, it's not, right? It's not the same node. So in this case, we're going to do the same thing. We're going to add 3's left children, which is 6. And we're going to do the same thing for the clone. So we're going to do this 6 and this 6 over here. Okay, so let's append that to our stack. So 6, 6. And finally, we had to go to 3's right children as well. So in this case, it does have a right child with the node 19. So 19 for the original and 19 for the clone. Okay, 19, 19. Okay, so at these two nodes, we're going to do the same things again. So now we pop this out. We have 6 over here. So we go to 6 and 6 over here again. And the same thing, and we're going to be doing the same thing, which is we're checking if 6 is equal to the target. Well, it's not the same node. So then we keep moving on. And again, but actually before moving on, 6 actually is a leaf. It does not have any children, so we don't append anything to our stack. So finally, we have one last and final value in our stack left, which is 19. So 19 for original, 19 for clone, and get them both. And well, they are the same node. 19 is equal to 19. So in this case, right, so again, just to be clear, this 19 is from the original, and the target is also from the original. So now that we've found the value in our original, and we have been doing the same steps inside of our clone as well, all we need to do now is return the same node, but the node has to come from our clone. So we're going to end up returning this 19, and that over there is going to be our answer. Perfect. Okay, so that should be it, and that's how a breadth first search works. And now let's just implement it in code, and it should be pretty simple to do. Okay, so I'm just going to do this exact same steps as what we did earlier, okay? So one thing that I'm going to do first is check if our tree actually does have a value, right? It's not an empty tree. So to do that, let's just do if not original, then in that case, we're just going to end up returning none, okay? So we can do that. And finally, we actually now have to initialize our stack. So for our stack, let's just start off with an empty list. So now that we have this, we're going to go inside of our while loop. So while stack, and we're going to keep going inside of this while loop until there's some sort of value in our stack. So to actually comply with that, in the beginning, we have to give it some sort of value. And what is the value that we're going to be giving it? Well, it's going to be the head nodes or the root nodes of, root nodes of both of the trees. So like I said earlier, we're going to be doing the original tree, comma, the clone, okay? So let's put them inside of a tuple. And the original tree, so let's go to original, and we're going to add that over there. And we're also going to get the cloned values, okay? So that's going to be the root nodes in the beginning. So now what we're going to do, we go inside of this, and we're going to pop out whatever we have in our stack. So to do that, we're going to do stack.pop, and we want to get whatever is at the 0th index, so pop 0. Okay, so one thing I want to point out is that using stack.pop0 actually takes quite a bit of time. So instead, to actually make this process a little bit faster, you could actually use the dequeue from collections. So you would import collections, and you would do collections.dequeue. So by doing that, what's going to happen is this over here is now going to be a dequeue object, right? And to get out whatever is at the 0th index, what we could do is we could use the .popleft function, okay? So stack.popleft is going to get whatever is at the 0th index. So in this case, we're actually going to have two values. So the first one is going to be a node from our original tree. So let's just call it OG, and we're going to have a node from our cloned tree. So OG, comma clone, we're just unpacking the values, okay? And now that we have this, all we got to do is we want to do this check. And the check is if our OG value over here is equal to our target. And if it is equal to our target, then in that case, we're directly going to end up returning our cloned value, right? So if we find the original value, which is equal to our target, then in that case, we return cloned. Okay, so return clone, that's all we're doing. Now, the other two conditions that we have is we want to, so let's say it's not equal to our target, then in that case, we have two conditions. And those two conditions are, the first one is that we want to check if there is something to the left of our tree. So to that, we can just do if og.left. So you might be thinking, why can't we do og.left? Or we could actually even just do clone.left. Doing either of them doesn't really matter because the trees by itself are the same thing, okay? So you can do og.left or clone.left, okay? And if it does have a value, then we're going to go inside of this if loop. So if statement. So if we're inside over here, it means that we do have a value to the left of the current node that we are on. So because that's the case, we're going to do stack.append, and we're going to append a tuple, and it's going to be the same thing. So it's going to be our OG value dot left because we want to go to the left by 1, and then we're also going to have our clone value dot left, okay? And let me just copy this over, and the other last step that we have left is we want to check if there's a right child, which is also there, right? So if there is a right child, we're just going to do if og.right, or you could also do clone.right, and we're just going to copy this over, and instead of going to the left node, we're going to go to the right node. Pretty simple. Okay, and that's all we're doing, right? And that should be it. So at the very ending, let's say our target does not even exist inside of our tree, right? So if it doesn't even exist in our tree, then in that case, we're just going to go over here and end up returning none at the ending of our stack. So let's submit this and it should get accepted. Okay, so finally, thanks a lot for watching, guys. Do let me know if you have any questions, and don't forget to like and subscribe. Thank you.